Hello, dear students. I hope you are doing well. Today I want to explain for you change of state, section 3 from chapter 11. Before I explain for you a new lesson, I want to explain for you some about the previous lesson, which is about the gas behavior laws. Okay? I explained it for you Boyle's law and Charles' law, okay? In a very short explaining, I will make a review for you, okay? Boyle's law states that the volume of a gas increases as the pressure decreases if the temperature does not change. If the temperature does not change, okay? This is the Boyle's law. Charles' law Charles' law states that the volume of a gas increases as the temperature increases. This is the opposite of the Boyle's law. When this gas increases as the temperature increases. In the Boyle's law, the gas will increase as the pressure is decreased. Here the gas is increased as the temperature increases, okay? If the pressure does not change. In the Charles law, the pressure does not change, okay? This is the point you must know. But in the Boyle's law, the temperature does not change. In the Charles law, the pressure does not change, okay? And let us restart with the changes of state, okay? In this section, you will learn about the four changes of state, which is melting, evaporation, boiling, condensation, and sublimation. Now let us restart. What is the meaning of a change of state? Is the change of a substance from one physical form to another. Change of substance from one physical change to another. All change of state are physical change. Why they are physical change? Because the identity of a substance does not change. As we explained in the previous lesson about the physical properties and physical change, the identity of the substance does not change, okay? And figure number 1 shows that the ice, we have what? We have ice, we have water, and we have gas, okay? When this ice is going to be melted, the state of this ice will be changed from solid to liquid. It's called melting. When the water is freezing, it's going to be changed the state of water from the liquid to gas, which is called freezing. And when this water is exposed to the heat, it's going to change the state of water from liquid to gas. It's called evaporation. When this gas is going to be water, the state of the gas will be changed from gas to the liquid, called condensation. Condensation. Okay? And now let's say what is a change of state. What is a change of state? Dear students, please bring your notebook and write with me what is a change of state. Change of state, the change of a substance from one physical state to another. From one physical state to another. From one physical state to another, okay? And we have here, we start with the first one, which is what? First one, melting, okay? Melting, first one, melting. This is number one, melting, change of state from solid to liquid. One change of state that happens when you add energy to a substance is melting. Melting is change of state from a solid to a liquid. This change of state is what happens when ice melts. When ice melts. Adding energy, adding energy to a solid increase the temperature of the solid, okay? As the temperature increase, the particle of the solid move faster. What? We said as the temperature increase, please highlight it with me because I will bring in the exam, okay? The particle of the solid move faster. When a certain temperature is reached, the solid will melt. The temperature at which a substance changes from a solid to a liquid is melting point. The temperature at which a substance changes from a solid to the liquid is called melting point. Melting point of the substance. Melting point is a physical property. Different substances have different melting point. For example, we have gallium. This is gallium. The melt at about 30 degrees centigrade because your normal body temperature is about 37 degrees centigrade, okay? Because of that, the gallium will melt in our hand. Gallium will melt in our hand. This is shown in figure number 2. But when we put the table of salt in our hands, it will be not melt because the melting temperature of the table salt is about 801 degrees centigrade, okay? Okay, let's we know what's the meaning of the melting. Is the change of state in which a solid becomes liquid by adding energy. And I will explain for you what's the meaning of adding energy. For a solid to melt, particles must overcome some of their attraction to each other. When a solid is at its melting point, any energy added to it is used to overcome the attraction that hold the particles in place. Melting is an endothermic. Melting is an endothermic change because energy is gained by the substance as it changes state. Because energy is gained by the substance as it changes state, okay? Okay, let us start with the number 2. Freezing liquid to solid. The change of state from a liquid to a solid is called freezing. The temperature at which a liquid changes into a solid is the liquid's freezing point. Freezing is the reverse process of the melting. You know, students, what's the meaning of reverse? It means the opposite of the melting is freezing. Thus, freezing and the melting occur at the same temperature as shown in figure number 3. If energy is added at 0 degrees centigrade, the ice will melt. If the energy is removed at the 0 degree centigrade, the liquid water will freeze. Removing energy for a liquid to freeze, the attraction between the particles must overcome the motion of the particles. Imagine that a liquid is at its freezing point. Removing energy will cause the particles to be locking into a place. Freezing is exothermic change. Exothermic change because energy is removed from the substance as it changes states. Okay? Energy is removed from the substance as it changes states. Number 3, we have evaporation. We have what? We have evaporation. Evaporation from liquid state to the gas. Okay, from liquid to gas. One we have an example about the evaporation, the iron steam. This steam, when we use it, forms when the liquid water in the iron becomes hot and changes to the gas. Evaporation is the change of a substance from a liquid to gas. Evaporation can occur at the surface of a liquid that is below its boiling point. For example, when you sweat, your body is cooled through the evaporation. Your sweat is mostly water. Water absorbs energy from our skin. As the water evaporates, you feel cooler because your body surface energy because your body transfers energy to the water. Evaporation can also explain why water in a glass on a table disappears after several days. Okay, students, and please, when I solve the self-checks for you, write in your notebook, okay? Write what is evaporation. Evaporation, the change of a substance from a liquid to a gas. Now we have boiling. Boiling is the change of a liquid to a vapor or gas through the liquid. Boiling occurs when the pressure inside the bubbles, which is called the vapor pressure, equals the outside pressure on the bubbles, or atmospheric pressure. The temperature at which liquid boils is called boiling point. The temperature at which liquid boils is called the boiling point. No matter how much the substance is present in the boiling or in the melting point of substance, for example, 5 milliliter of water and 5 liter of water both boil at 100 degrees centigrade and freeze at 0 degree centigrade, okay? And we have what the difference between the boiling and evaporation. Boiling and evaporation. If I bring it for you in the exam, students, what's the difference between the boiling and evaporation? You must know these points, okay? Boiling occurs in a liquid at its boiling point as energy is added to the liquid. Can also occur in a liquid below its boiling point. But boiling particles through the liquid move faster. When they move fast enough to break away from the particles, they evaporate and become a gas. Some particles in evaporation at the surface of the liquid, this is at the surface of the liquid, move fast enough to break away from the particles around them and become a gas, like this. Okay? Okay. And let us we are going to the another things, which is effects of pressure on boiling point. Earlier, you learned that water boils at 100 degrees centigrade. In fact, water boils at 100 degrees centigrade only at sea level. Because of what? Because of atmospheric pressure. Atmospheric pressure is caused by what? By the weight of the gas that makes up the atmosphere. Atmospheric pressure is lower at higher elevation, okay? The higher you go above sea level, the fewer air particles there are above you. Okay, imagine that boiling water at the top of the mountain, the boiling point will be lower than 100 degrees centigrade, okay? And we have number 4, we have condensation. Condensation, it means the change of state from gas to what? To liquid, from gas to liquid. Look at the cold glass of juice in figure number 5. Note the beads of the water that have formed on the glass. They form because of the condensation of gaseous water in the air. Condensation is the change of state from a gas to a liquid. Condensation and evaporation are the reverse of each other. Like the freezing and melting, they are reverse of each other. Here, condensation and evaporation, they are reverse each other. Okay? For a gas to become a liquid, large numbers of particles must clamp together. Particles clamp together when the attraction between them overcomes their motion. For this to happen, energy must be removed. For this wants to be happen, energy must be removed from the gas to slow the movement of the particles. When we remove the energy, the movement of the particles will be slow. Because energy is removed, condensation is an exothermic change. We said also freezing, also in the freezing energy is removed. It is exothermic change, okay? In the melting is adding of energy, they are endothermic change. Condensation, the change of a state from a gas to liquid. From a gas to liquid. And we have the last one, which is the 5th one, sublimation. Sublimation from solid to gas. From solid to gas. The solids shown on the left in the figure number 6, we have this dry ice, and is carbon dioxide in a solid state is called dry ice because instead of melting into a liquid, it goes to the sublimation. And instead of this dried ice melt to the water, is going to be from the solid to liquid, it goes to be melting into a liquid, is going through a sublimation, is the change of state in which a solid changes directly into a gas. Dry ice is much colder than ice made from water. This dry ice is much colder than this ice which is made from the water. For a solid to change directly into a gas, the particles of the substance must move from being very tightly packed to being separate far apart. So the attraction between the particles must be completely overcome. The substance must gain energy for the particles to overcome their attraction. Sublimation is an endothermic, okay? Sublimation is an endothermic change because energy is gained by the substance as it is changing state. Okay, students? We have sublimation, the process in which a solid changes directly into a gas.
Change